Hello everyone, welcome back to Digital Code Lab. Today I am going to start one of the most important topic of object-oriented programming in C++ is inheritance. And also today we will learn reusing and extending classes, how to reuse the class, how to extend a class into another class. Have you ever copied the same code into multiple classes? Suppose you have class number 1, class number 2, class number 3, and if any code you want to reuse, so have you ever copied the same code into multiple classes? It makes the program longer, harder to maintain, and increases the chances of errors. Inheritance solves this problem by allowing us to reuse existing code and extend it with new functionality. By the end of this lecture, you will understand what is inheritance, why we need it, and different types of inheritance, as well as we will also discuss about access specifiers, advantages and limitations, and we will discuss some real life applications, real world applications. So let's begin with the title, reusing and extending classes. These two words summarize the idea of inheritance. Reusing. What is the meaning of reusing? Reusing means don't rewrite code that already exists. Extending. Extending means we can add new features without changing the original class. Think about a mobile phone. Every new smartphone already has features like calling, messaging, and taking photos. Instead of creating those features from a scratch, every time manufacturer reuse them and then add new capabilities like AI cameras for better processors. Inheritance works in exactly the same ways in the program. Instead of writing the same code repeatedly, we reuse an existing classes and extend it with additional functionality. Why do we need inheritance? Now, let's understand why inheritance is necessary, why inheritance is needed. The first point is eliminate duplication. Imagine you have three classes like student, teacher, and a staff. All three contains attributes like name, age, and address. Should we write those variables three times? No. Instead, we create one base class that is called person, and all three classes inherit those common features. This reduces duplicate code. The second point is reuse existing code. When the base class is already tested and working correctly, we don't need to write it again. We simply inherit it. And the third point is easier maintenance. Suppose you need to update the way a person's name is displayed. Instead of changing it in every class, you only update the base class. Every derived class automatically receives the updated version. Now, look at the image showing parents and child relationship. Parent and child relationship. Children naturally inherit characteristics such as eye, color, height, or hair color from their parents. Similarly, in programming, a derived class inherits data member and member function from the base class. That's why inheritance is often explained using family relationship. Now let's define inheritance. What is inheritance? Inheritance is nothing. Inheritance is a mechanism in which one class acquires the properties and behaviors of another class. The existing class is called the base class or parent class. The new class that is called the derived class or child class. Look at the diagram. Animal here, animal and dog. A dog is also an animal, right? So by the help of inheritance, first thing we can reuse and extend the properties as well as extend the some features. Another thing what you can do by the help of inheritance, you can make relationship between two or more than two classes. Which type of relationship you can make? By the help of inheritance, you can represent each a relationship. If I will say dog is an animal, yes. Similarly, suppose you have any fruit class, right? And you want to make any class mango. Yes, mango is a fruit. So similarly, person is already a class and person having some properties already given. And if you want to make a student, if you want to make teacher, yes, a student teacher, the student is a person. Similarly, teacher is also a person. So each a relationship we can maintain using inheritance. So here you can see animal and dog. So an animal can eat, sleep and breathe. A dog is also an animal. So instead of creating those common function again, the dog class simply inherits them. And the dog class can also introduce its own behavior such as bark. That is not given in animal. Every animal cannot bark, but dog can bark. This is the beauty of inheritance. We reuse existing feature and add new ones. Basic syntax of inheritance. Let's understand the syntax. We first define the base class. Base class is nothing. It's existing class. Just like a normal class you are creating. Suppose you have created any class. That is your base class, right? It contains a function that called display. Suppose here I created a class base where inside the public section, public access specifier since I have used, void display function is given here and where I am going to write base class. Now I close this class. This is a simple class, right? Next, we define the derived class. How? See, class derived, new one class name, right? New class name here you will write and then colon, visibility mode. This is called visibility mode. How you want to inherit the class into another class. Suppose I want to inherit base class. So how? Publicly, privately or protectedly. Since there are three types of access specifier are there. Public access specifier means everything will be visible in entire block of code, entire program. If you have written private, means it will accessible only and only inside the, suppose here I have written private, then it will be visible only and only inside this class, right? And here, if you will inherit it privately, then what will happen? If you will inherit it publicly, yes, public section of the base class will be public here, right? But if inside the public section, inside the base class, public section are there, like display function is there. Suppose I have some data member are also present, that is also public. But if you will inherit it privately, in place of public, if you will write private, what will happen? Everything of a base class public will become here in derived class private. And if it will become private, you cannot access it outside. And protected. Protected always be used in case of uh, inheritance, right? Suppose a base class having uh, any protected data member or protected member function, right? It will be visible inside the base class as well as derived. So this is called what? You have to write class, new class name, like here I have written derived. You can take any name, colon, then visibility mode, either public, private and protected. If you want to keep it public, always you should keep it public. And parent class name, from where you want to extend this. And again, you have to use all the things like public, private, protected, access specifier that you want to use. And here you can take new data member function. Now you can see display is by default virtually present here, since you have inherited class base into class derived. So class derived colon public base, this line means that the derived class publicly inherits from the base class, and because of public inheritance, the derived class can directly call display without redefining it. Understood? It also has its own function, that is what? Show function, that I already discussed. You can think another example. Suppose we have a vehicle class with function start. Suppose you have created any class that is a vehicle that having a function start and a stop. A car class inherits these functions and adds a new function that calls open sunroof. Obviously, every vehicle having a start and a stop. And if you are going to make any class car, again you have no need to define the behavior, a start and a stop. You can inherit this from vehicle class because car is a vehicle, I can say. And new member function here you can include, that is what? Open sunroof. This is a perfect example of extending an existing class. Now, types of inheritance. This is very important part. C++ supports 5 different types of inheritance. Single inheritance, where one parent and one child relationship, like this. One parent, suppose A is a parent and B is a child of this. Means A having the property and behavior that B is going to acquire or inherit. Second is multi-level inheritance. Multi-level inheritance is a chain of inheritance where one derived class becomes the base class of another. Like this. This is the example of multi-level inheritance. A, B, C. You can see here B. B is going to inherit the properties and behavior of A. Means A is a parent, B is a child. I can say. And C is again going to inherit the properties and behavior from B. Means C is a child and D is a parent, right? So C have by default all the properties and behavior of A. You can take this example, like real life example, you can say that grandfather. A I am going to assume as a grandfather. B, father, your father, suppose acquires or inherited the properties and behavior of your grandfather. Obviously, because he is the father of your father. Again, you are going to inherit the properties and behavior from your father, right? So, A is a grandfather, B is a father, and C is a son. So this type of chain of inheritance, if you will make, that is known as what? Multi-level inheritance. Okay, one more thing. Suppose here parent-child relationship. Here you can say that father or son, right? Here you have no need to create the object of class A. Means you have no need to create the object of parent class. By default, if you will create the object of B, uh, everything is exist because you have already inherited this from A. So you will create the object of class B, and by the help of B class object you can access all the properties and behavior of B as well as A. So similarly here also you will create the object of C, and by the help of C object you can access C class property behavior as well as B class as well as A class. Next is multiple inheritance. Multiple inheritance is one of the type of inheritance where one class inherits from two or more than two parent classes, right? Like here I told you in single inheritance, a father and son relationship I can say, right? Means son is going to inherit the properties and behavior of father. But I can also say that now father, a son can inherit properties and behavior of father as well as mother. So if two class will be base class and a single class will going to inherit the properties and behavior of two or more than two classes. At that time, we can say that this is the type of multiple inheritance. Means one class will inherit properties and behavior of two or more than two classes. Here, A and B both are base classes, and C is going to inherit the properties and behavior of A and B. Then, hierarchical inheritance. Hierarchical inheritance is one of the type of inheritance where one parent class has multiple child classes, right? Like this, A is a parent and A having three children, right? So you can say that a tree type, a structure if you want to represent, a family tree if you want to make, yes, you can use hierarchical inheritance. Here you can also say that grandfather. In place of A, you can take grandfather. Grandfather having two or three child, right? And again, father, uncle, and another uncle, right? And father having again children, uncle having again children. So that type of relationship, if you will try to represent, you have to represent through hierarchical inheritance. Means one parent having two or more than two children, that will become what? Hierarchical inheritance. A tree type structure. Just like a tree having one root and multiple branches. Next is hybrid inheritance. Hybrid inheritance, a combination of two or more inheritance types. Means if you will combine any of two types of inheritance or more than two types of inheritance, you can say that yes, it's a hybrid inheritance. Like That suppose I will remove D. What will happen? A having two children means A having two children. It will become which type of inheritance? Hierarchical inheritance. One parent, two child. But if I will include this D, suppose if I will hide A, B and C, two base classes are there, and these two, from two base classes, I am going to derive one class, that is what D. Means two parent, one child relationship. Which child type of inheritance is? It's multiple inheritance. And if I will merge all, then it will become hybrid. How hybrid? Because A, B, C, this is a hierarchical inheritance, and B, C, D, this is a multiple inheritance. And if I will combine all, then it will become multiple plus hierarchical hybrid inheritance. And this is very important topic that will again and again ask in lecture. Now, single and multi-level inheritance. First, let's first look at single inheritance. The diagram shows animal and dog. Animal and dog. Class A, class B. In place of that, if I will see animal and dog. Dog is a animal. Means a parent class is animal, and dog is going to inherit the properties and behavior of animal. Now, dog, the dog class inherits common behaviors like eat and sleep from animal and add bark. Now look at multi-level inheritance. The image shows grandparent, parent and child. Grandparent, parent and child. Here, the parent inherits from the grandparent and the child inherits from the parent. As a result, the child indirectly receives feature from the grandparent. This is useful when building software with multiple levels of specialization. For example, person and employee and manager. Next, multiple and hierarchical inheritance. Now let's understand two more types. That is first the multiple inheritance. The diagram shows a sports and academics combining into a student. A sports academic combining into a student. So a student is going to inherit the properties and behavior of sports as well as academics. And so two parent, one child, I can say that, but multiple. Next is hierarchical inheritance. Here one base class vehicle is inherited by car, bike and bus. Obviously car is vehicle, bike is also vehicle, bus is also vehicle. Means one parent, multiple childs. So this is called what? Hierarchical inheritance. Each derived class shares common features like a start and a stop that is given in vehicle, while also adding its own unique functionality. This approach keeps the software organized and avoid code duplication. Access specifier, as previously I already discussed. Again, I am going to briefly discuss about access specifier. Now let's discuss access specifier, the types of inheritance: public, protected or private. Because visibility mode, either I can give public, private or protected. Determines how members of the base class are accessed in the derived class. Public inheritance keeps public member public. Protected inheritance converts public member into protected. And private inheritance converts converts inherited members into private. In real world software development, public inheritance is the most commonly used because it prevents the logical edge of relationship. Advantages and limitations. Inheritance offers many benefits. It promotes code reusability. It speeds up development because existing code can be reused. It simplifies maintenance since updates in the base class automatically affect derived classes. It also creates a clear and organized class hierarchy. However, inheritance has some limitations also. Very deep inheritance structure become difficult to understand. Derived class are tightly coupled with the base class. So changes in the base class may affect with child class. If you will do changes in base class, that will affect in child class. Also using inheritance where it is not appropriate can make software harder to maintain. So inheritance should always be used carefully. Real system and conclusion. Finally, let's see where inheritance is used in real application. In banking software, we have an account class that is extended into saving account and current account. In a school management system, a person class is extended into student, teacher, and staff. Obviously, person is also student is also person, teacher is also person, a staff is also person. In e-commerce platform, a product class is extended into electronics, clothing, and books because all are product. So these examples shows the inheritance is not just a theoretical concept, it is widely used in professional software development. Let's summarize today's lecture. What inheritance is, why it is useful, and the syntax of inheritance, the 5 types of inheritance, access specifier, as well as advantages and limitations and real world applications. So, inheritance is one of the 4 pillars of object-oriented programming and helps developers to create reusable, organized, and maintainable software. Thank you for watching this lecture. If you found it helpful, please like the video, share it with your friends, and subscribe to Digital Code Lab for more C++ and Java and data structure and other programming tutorials. If you have any question, feel free to ask in the comment. I will happy to help you. Okay. See you in next lecture. Happy coding.